understand theorem 10.1, which states that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Before we see the proof of the theorem, let's recall from grade 9 that the perpendicular line segment is the shortest of all the line segments drawn from a given point to the line. That means from any given point which is outside the line, the given point outside the line, so P is outside the line, and from all the line segments that you can draw from P to the line, the perpendicular line segment, which is PM here, which is perpendicular, is going to be the shortest line segment. So here PM is the shortest line segment. We are going to use this result to prove theorem 10.1. Theorem 10.1. The tangent at any point of a circle is perpendicular to the radius through the point of contact. So we are given that O is the center of the circle. So you can see here O is the center of the circle and line XY is the tangent to the circle at a point P. So XY is a tangent to the circle and P is the point of contact. We need to prove that OP, the radius, this is the radius, OP, is perpendicular to XY. So we need to prove that OP is perpendicular to XY. Okay. For this, we will have to do some construction. So let us take a point Q on XY. So we take another point Q on XY other than P. That means Q is not the point of contact. It's some other point. And now we join OQ. So we join this line OQ. Okay. Now let us understand the proof. Q is a point on the tangent XY other than the point of contact. Now Q is the point we have constructed, but it is other than the point of contact. Therefore, Q is outside the circle. Q has to be outside the circle. And because it's outside, we can say that OQ, line segment OQ, this line segment OQ, is longer than the radius OP. It is always going to be longer than OP, of radius OP of the circle. And that is, we can write it like this, OQ is greater than OP. Now, if you take another point R, let's say R, on the tangent, then R, because it's on the tangent and it is not the point of contact, it is also going to be outside the circle. And if you join OR, OR is going to be greater than OP, the radius. So again, OR is going to be greater than OP. Same will be for any other point S. Let's say on this side, and if you join OS, because S is outside the circle, OS is going to be greater than OP. OS is going to be greater than OP. Since this happens for every point on the line XY, except the point P, except P, for all the points on line XY, if we join it with the center of the circle O, we will get the line segments which are longer than the radius. So we can say that OP is the shortest of all the distances from the point O to the points of XY. As we know that the shortest line segment drawn from a point which is outside the line to the line. So the shortest line segment drawn from a point which is outside the line to this line. So this is the shortest line segment which I can draw. Then that line segment is always perpendicular to the line. We can say that OP is perpendicular to XY.